Hey friends, a few weeks ago I uploaded a short highlight video of this little 3D printed 75mm Deadcat build. So I'm here now to follow up with a more in-depth build video just to share the design process, how it flew for me, and my thoughts on 3D printed quad frames in general after having gone through this admittedly limited experience. Now, for context, when I decided to do this project, I was just starting to explore 75mm whoops for backyard freestyle type of flying, and coincidentally had this Odinata build lined up, which as we can see here is an X-frame configuration. So for variety's sake, I opted to go with the Deadcat configuration on this design with the intent on keeping true to the 75mm footprint. So with that context, let's dive on into the design process. Alright, so I've been trying to get a feel for Onshape for some time now, and this project turned out to be the perfect opportunity to actually sit down and get a little familiar with the software. So I've gone ahead and rolled back to the initial sketch here, and we can see that I started out with the dimensions that I knew I wanted, which was for the diagonal center to center distance to be as close to 75mm as possible, and for the frame to have that Deadcat configuration with the front arms more stretched out and the rear arms tucked in a little closer to each other. And essentially that's all the science that went into this design. From there I extruded motor mounts and the subsequent base plate of the frame itself. Then I added a rear bridge here and mount lugs for the AIO to attach to. Next I added ribs for structural integrity since this will be 3D printed plastic, and I went ahead and added some reliefs to the main frame to give the motor wires and plug some breathing room. Then I modified the rear lug here of the AIO to make sure there would be room to plug a cable into it. And I also made counterbores in the arms so the motor clips don't bind up against the frame. From there, I started shaping a set of camera standoffs, and then I added reinforcement ribs and canopy mount holes to that, and went ahead and blended in those standoffs into the front leading edge of the frame. Next, I shaved some thickness off the deck of the frame to reduce some weight, and slapped a copious amount of fillets and chamfers on there to clean up the inside corners and edges. Then of course I made an accompanying canopy that would mount to the front standoffs here and bolt through the rear AIO mount. It also has slots at the front and a tab at the back to capture rubber bands for the battery, and I also removed some material from the underneath just for additional weight reduction. This process took a few design and print iterations to get the frame that I flew, but even after that I went ahead and modified the frame further just to accommodate all 25x25 AIOs and not just the Beta FPV Cross AIO that I had picked up for this particular build. Now here we can see the assembled frame and canopy, and if you're starting to wonder what electronics I have in mind for this build, I picked up this used quad specifically to swap its electronics into my frame. And for those part info junkies out there, those components consisted of a Beta FPV-1S ELRS AIO, a Happy Model OVX303 VTX, a CADX Ant Nano camera, and a very cool looking set of Flywoo Robo 1002's 23,500 kV motors. And I personally was really excited to check these motors out because they're some of the lightest KV 1002s that I could find, and they have a 1.5mm shaft. And for what it's worth, I opted to run the GemFan 1610 bi-blade props. Now, as I mentioned earlier, I printed a couple iterations to tweak the locations and fitments of various components, and then it was off to the backyard to test a few battery packs. Now, fortunately, I thought it flew pretty well for an early iteration, and it was kind of fun to get used to. Obviously, without ducts, it's a little more drifty, so more dramatic banking was necessary to make it around turns, but it also tosses better, which is what I was hoping would open up opportunities to develop other skill sets. Anyhow, about 20 packs, and the frame definitely was starting to show some decent signs of wear. I had been through a few good tumbles, including a couple good hard hits, and the front arms had required bending back straight a couple times at that point, were showing stress cracks where they meet the frame. Regardless, the frame was holding together, so I was still flying it. Unfortunately, in an unrelated issue, a few 6 packs of batteries in later, the video transmission would just intermittently drop out, and I wasn't quite sure if it was the VTX or the flight controller or what was going on. And unfortunately, it just wasn't the biggest priority at that time, so it sat for a couple weeks. Then when I was packing up for an out-of-town trip and throwing my other whoops in a bag, I decided to bring it along and tempt fate and as one might expect on a nice cool late evening after a long day on the road whilst just trying to get some stick time in, quite predictably the inevitable occurred, and I lost video. This time it wasn't over grass, and while I did try to set it down gently, I didn't manage to scrub off enough altitude before I flipped the disarm switch, and yeah, there were consequences. So here we are, and obviously I assumed at some point an arm was going to break, but for whatever reason I didn't really think about what exactly was going to happen with the motor. Not surprisingly, it just ripped the motor wires right off. But perhaps it's not a total loss. I did kind of end up picking away at this rubber coating on the back of this board here, and I did discover these little pads that appear to still be intact, so I may be able to just solder some wires back on there and recover this guy. Regardless, in the grand scheme of things, if it doesn't work out, it was a $13 lesson, and I've already got a spare sitting in a box ready to rock and roll. On top of that, it still does have the pending video transmission issue to deal with, and obviously the electronics are going to need to be swapped over into another frame, but I already know that's not going to be another printer frame. This stuff is actually going to be going into a Flywoo TC16 carbon fiber frame, which also is another Deadcat frame, just to keep that variety in the fleet. Which brings me to my general takeaway regarding 3D printer frames. I think this was a super fun project, but ultimately that's all I think these are when it comes to 3D printer frames. Clearly the strength to weight ratio on 3D printed plastic is not going to be on par with carbon fiber, and while I admit it flew and held up much better than I initially anticipated, the small footprint of this design made it one of the better case scenarios for 3D printing to be successful. I can only assume that on a larger scale build like a 5-inch, a 3D printed frame is going to be significantly less durable. So for the cost of losing motors and other components, and the added inconvenience of just having to replace a frame so frequently, I just feel that 3D printed frames are kind of less than ideal. All that aside, like I said, I did have a lot of fun with this project. If you stuck around this long, you have my sincerest gratitude. Please make sure to like and subscribe, and of course if you have any thoughts on content you'd like to see, please leave a comment, and I'll leave you with a 1-pack rip in the backyard to enjoy without having to listen to me carry on. Peace out, friends.